Write a function, well-formed string, that takes in a string containing a bunch of brackets and check if it is well-formed. A string is well-formed if every single opening bracket has exactly one corresponding closing bracket. So here, we can assume that the string only contains these three types of bracket characters. So here are some examples of well-formed strings. So here, in the square bracket, there's a pair. In the normal bracket, there's a pair, and in the curly bracket, there's also a pair. And here, notice that everything is paired up. And next, here are some non-well-formed bracket strings. So over here, notice that our closing curly brace is actually missing. And over here, notice that our leftmost and rightmost bracket doesn't match. And here, notice that there's a missing opening bracket. So do pause this video and take some time to give this a go before taking a look at the answer. So before we jump right into writing our function, let's plan on pen and paper how this works. So here, let's start with a positive example first. So we have a square bracket, a curly bracket, these two, close curly bracket, open curly bracket, these two, close curly bracket, and square bracket. And next, we are going to maintain a stack. So next, we'll iterate through each of these, and we'll use the stack to check if the brackets are well formed. So firstly, we have this, and we add it into the stack. And next, we have this, and we add it also into the stack. Next, we have another opening normal bracket, and we also add it to the stack. However, after this, we have a closing normal bracket. So at this point, whatever closing bracket we have must correspond to the top opening bracket in our stack, which is this. So they correspond, so we cancel both of them out. And afterwards, we have this. So this will cancel this out. And we move on to our next opening curly bracket. And afterwards, we have our opening normal bracket. And once again, a closing normal bracket, which will cancel out this. And next, we have a closing curly bracket, which will cancel out this. And finally, we have our final closing bracket, which will cancel out this. So at this point, we can see that for a string to be well-formed, there must be nothing left in the stack afterwards. So next, let's use a negative example. So firstly, we have opening bracket and another opening bracket. And next, we meet our first closing bracket. So here, this closing bracket will cancel out our opening bracket over here. And next, we move on to the next opening bracket. Another opening bracket. And over here, we have a closing bracket, which will cancel this out. And afterwards, we have another closing bracket, which will cancel out this. And finally, we have another closing bracket. But notice that this is the wrong kind of bracket to cancel out with our square bracket here. So at this point, we know that our string is not well formed and we return false. So with this in mind, we can start writing our function. So here, define well formed, and we take in a string. So first things first, we create a stack is equals to list, and we iterate through string. So here for character in string, we first print character, and let's try this on a well-formed string. So let's run this, and we'll just get all of the brackets. So next, let's add all opening brackets into our stack. So if C in stack append C, and else, which means we meet a closing bracket, we first have to check whether this closing bracket corresponds to the top of our stack. So here, top is equals to stack dot top. And next, we need to check whether top corresponds with C. And here we can do it using a dictionary. So D is equals to open bracket corresponding to close bracket, open bracket corresponding to close bracket, and open bracket corresponding to close bracket. So here, we have our expected close bracket is equals to D top. So if expected is equals to C, we continue on our way. However, if it is not equals to C, we know for sure that this is wrong, so we return false straight away. And at the end of our function, we need to check whether our stack is empty. So at this point, let's run this and we should get a true. However, if we choose to remove a bracket here, it should now give us a false. And similarly, let's add this back and let's remove one bracket from the front. And if we run this again, we might get an error. And this is because stack is empty at this point. So here, if length of stack is equals to 0, we return false. So here, if we reach this point and stack is empty, it just means that there is no opening bracket that corresponds to a closed bracket that we just found. So here, let's run this again and we should get a false now. So let's add this back and let's replace this with a round bracket. And here we should still get a false. So let's check these three and they should all be false. So this is false. And let's check this. And this should also be false, which is correct. And finally, let's check this. And if we run this, we should also get false. So here we have successfully solved this function. So once again, thanks for watching and hopefully this was clear and easy to understand. See you in the next one.